Okay, this is page 3 of the Chapter 13 review worksheet. Number 27, we're given a graph in the form of A is the sine of x plus d, and what we want to focus on is the amplitude of this function. So it looks like, because sine starts in the middle of the function, like the midline is right here at positive 8. So this thing is shifted 8 up, but then the amplitude from there, it goes to up to 12, which is 4 above 8, and then down right here to 4, which is 4 below 8. So it appears that the amplitude is 4 for that function. And it would be a positive, so the amplitude is, the absolute value of A. It would appear that A is probably a positive 4 because this is sine function, it goes up. Okay, so then in number 28, we've got a diagram, and we're told that pi is negative pi over 3, so this is an angle of negative pi over 3, and we're supposed to find the value of y, which would be the sine of the function. So at negative pi over 3 radians, that's the same as positive 5 pi over 3 radians, so the sine of that function is negative root 3 over 2. Okay, so that would be the y value. Number 29, we've got the angle of a circle, and we're supposed to find the length of a radius, and I know an arc length. So because the arc length, s, is the angle measured times the radius, and I know that the arc length is 18, and the angle measure is 1.5 radians, and the radius is this. If I divide both sides by 1.5, I'll get that the radius is 12 centimeters. Number 30, which graph is symmetric with respect to the origin? Well, sine of x is the graph that has origin symmetry. Cosine of x is odd function. An even function, it has y-axis symmetry. So sine of x has origin symmetry as an odd function. Okay, number 31, again, we've got an intercepted arc. So we're using that the arc length is the measure of the central angle times the radius. And so the arc length is 3 pi over 2. And the central angle is pi over 2. That's given here. Pi over 2 radians times r. So in solving, if I multiply both sides by 2 over pi, the 2's cancel, the pi's cancel, and I get r is 3. So that would be 3 units, or in this case 3 centimeters. In number 32, I have an arc that's 5, and it has a central angle. It's subtended. It means it's related to the central angle of 5/3 radians. What's the radius of the circle? So again, the radius of the circle is what we're solving for. So this is 5/3, and this is an arc length of 5. So multiplying both sides by 3 over 5 to solve for r, the 5's cancel, and I get r is 3, and that would be in some units. Number 33, I'm supposed to look at the hands of an angle that's 7 o'clock. So 7 o'clock would come down, and it would be, each of these would be, there's 6 on a side, 12 in all. So 6 parts, so this would be 1/6 of a part here. So in looking at my unit circle, that would come down, and 7 o'clock would go right off here to 4 pi over 3. So if I think of 4 pi over 3, what's the difference between 4 pi over 3 and pi over 2? That would give me this arc length, or this angle measure. So I can just say that 4 pi over 3 minus pi over 2. And so to get this all over 6, I can multiply this by 1 in the form of 2 over 2, and this by 3 over 3. So this would be 8 pi over 6 minus 3 pi over 6. So that would be 5 pi over 6. And the other thing we could do is look at this as if this was the horizontal axis, and it would come over like it would be this many degrees, which would be on 5 pi over 6. Okay, number 34, number of degrees in an angle whose radian measure is 11 pi over 12. So I'm taking 11 pi over 12. I multiply it. I want to get rid of the radian, so the 180 is on top, and these cancel, and I can simplify, and I'll get 165 degrees. In number 35, I'm going to take degrees, and I want to get rid of degrees, so I'm going to divide by 180 degrees and multiply by pi. And when I simplify this fraction, I've got divisible by 5. This is 47. And when this divides by 5, this is 36. And I have a pi up here. So 36, they want the minimum value of this function, 3 times the sine of 4 theta. So there's no, d is 0, so my midline is just the y-axis at 0. So my amplitude is 3, so my max value will be positive 3, and my min value will be negative 3, so the min's at negative 3. Number 37, they want the amplitude of this function, so there is a. So the amplitude is the absolute value of a, or 2/3. In number 38, they want the maximum value of this function. So I'm going to rewrite this as 3 times the sine of x plus 1. So d is 1. So my baseline will be at d, and I'm going to go up 3 above that and down 3. So my max is going to be at 1 plus 3, or 4, and my minimum value will be at 1 minus 3, or negative 2. So I'm asked for the maximum value, so that would be at positive 4. In number 39, I've got to find the range of this function. So I can see that d is 0, so it's not shifted up from the x-axis or down. So my amplitude is right here. If my amplitude is 2, then my max value is positive 2, and my minimum value is negative 2. So the range is all the y values, all the values that y can take. So it'll never go below negative 2, and it'll never go above 2. So it's in that interval. And then number 40, the period of this function, well, b right here is 4. So the period is 2 pi over b, or 2 pi over 4, which is pi over 2, which is a short period, making this a fast function. And that's page 3.